Alright, today we're going to do a quick review of Chapter 8. If you are just preparing for your test, I would suggest skipping through these questions to just focus on the ones that you don't know, and then maybe going through quicker the ones that you do know. So first it says simplify the expression, write your answer using only positive exponents. So this is y to the power of 9, meaning that's 9 y's. If you want, you can write it out. 5, 6, 7, 8, 9, and then over here we also have one more y, it's really y to the power of 1. So for a total we have y to the power of 10. There's 9 and one more. You don't need to show your work to write that out if you don't want to. Next, we need to write anything that's inside our parentheses, however many times the exponent says. That exponent tells me I'm going to write y to the 4th 6 times. So I'm going to write y to the 4th, y to the 4th, y to the 4th, y to the 4th, 1, 2, 3, 4, 6 times, y to the 4th, y to the 4th. So each one of these, if you want to make a table, you can. Some of you might be able to tell already this is 1, 2, 3, 4 y's, 1, 2, 3, 4, 5, 6, 7, 8. All of these are y's. Some of you might be able to just count here 4 plus 4 plus 4 plus 4 plus 4. Or multiply 6 times 4 is 24 y's. Oops. Y to the power of 24. Because this would be 4 plus 4 is 8, 9, 10, 11, 12, and 16, 18, and 24 total. Alright, taking a look at the next one. This one's a little bit more complicated. I need to write this whole piece 3 times first. So I have 1 over 2y to the 5th, 1 over 2y to the 5th, 1 over 2y to the 5th, and then I have this piece here 4 times. It says 2y squared, 2y squared, 2y squared, and one more time 2y squared. So I need to combine all of my y's and all of my numbers. This is really all one big fraction. The only thing that's on the bottom would be the 2's, because I could put this over 1, this over 1. All of these would really be on the top. There'd really be 1's on the bottom, which we really don't need. So if I simplify this, on the top I have 5 y's, 1, 2, 3, 4, 5. Another 5 y's here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Here's 2 more, 1, 2, 1, 2, 1, 2, 1, 2. So we have 5, 10, 15, 16, 17, 18, 19, 20, 21, 22, 23 y's, or y to the power of 23. On the top we have 1 times 1 times 1, which is 1. And then we have 1, 2, 3, 4 2's, 2 to the power of 4. On the bottom we have 2 times 2 times 2, or 2 to the power of 3. Before you did that, you could have canceled some of the 2's out, or multiplied 2 times 2 is 4, times 2 again is 8, times 2 is 16, y to the 23rd, and 2 times 2 is 4, times 2 is 8 on the bottom. We could have simplified these numbers by dividing by 8 to leave us 2y to the 23rd over 8 over 8, which is just 1, or just 2y to the 23rd. Oops. If you left it like this, technically that's okay, but since we have the same number on the top and the bottom, we should simplify or cancel some there. Let's take a look at the next slide. Alright, we have 10 to the power of 5, so we really have 5 tens up here, another 5 tens, so if you want you can simplify. You know there's 10 tens, there's 5 here and 5 here. On the bottom you have 4 tens, so if you'd like you can write them all out, but you know that 4 of them are going to cancel out. You could write, like I said, 10 times 10 times 10 times 10 on the bottom, 10 times 10, and so on the top. We know that 4 sets of 10s are going to cancel out, leaving us with 6 left over on the top. So we'd have 10 to the power of 6 on the top, because those would go away, and 6 would be left over. Down here, we can write this 3 times. 4c over d to the power of 2. 4c over d to the power of 2. 4c d to the power of 2. So we're going to simplify here. We have 4 3 times, or 4 to the power of 3. We have c 3 times, or c to the power of 3. And this is really 2d's here, 2d's here, and 2d's here. So we have d to the power of 1, 2, 3, 4, 5, 6. This would be an awesome answer if you simplified 4 to the power of 3. We know 4 times 4 is 16, and 16 times 4 is 64. If it's 3 or less, I would suggest multiplying it out. And then our last one on here, if one's a fraction and the other is not, make them both fractions. So 8x to the 7th times 1 is just still x to the 7th. 1 times x to the 8th is really just x to the 8th. So we really have 7 x's on the top and 8 x's on the bottom. So 7 of them are going to cancel out and leave us with just 1 x on the denominator or on the bottom. One more slide of exponents. Remember that when we write things, we only want positive exponents. So anytime we have a negative exponent, like y to the negative 6, we have to move and make positive. So only move the negative exponent, that base, and that exponent there. So the 8x to the 7th stays on the bottom, and the y to the power of 6 is now on the top. The exponent with the negative became a positive. And that's our answer. We can't simplify anything else. Alright, before I simplify moving my negative exponents here, I'm going to write this out 2 times on the bottom. So I have 12x to the 8th, y to the negative 7th. And then on the bottom I have 4x to the negative 2, y to the negative 6th, 4x to the negative 2, y to the negative 6th. So I wrote that 2 times. So now I'm going to move my negative exponents. This needs to go down to the bottom. The x's, not the 4, because the 4 is a positive exponent, goes to the top, y to the negative 6 to the top, the x to the top, and this y to the top. The 4's are going to stay on the bottom, so I have those 4's on the bottom there. The 12, x to the 8th stays on the top. And then the things that we moved, this y to the 7th is now on the bottom, the positive exponent. This x squared is now on the top. This y to the 6th is now on the top. This x squared is now on the top. And this y to the 6th is also now on the top. So I'm going to simplify my x's and my y's on the top and the bottom. So on the top I have a 12, and then I have 8 x's here, plus 2 more gives me 10. Another 2 more gives me 12 x's, so x to the 12th. We also have y's. I have 6 y's here, 1, 2, 3, 4, 5, 6, and 6 y's here, 1, 2, 3, 4, 5, 6. So total of y to the 12th. On the bottom, 4 times 4, I'm just going to multiply and make 16. And then I have y to the 7th on the bottom. If we have y's on the top and the bottom, we need to simplify them. There's more on the top, so I know 7 will cancel out. And 12 take away 7 here would leave me with 5. While I'm at it, I'm also going to divide by 2. Well, actually, I'm going to divide by 4. These both go into 4, so even bigger number we can divide. 12 divided by 4 is 3. 16 divided by 4 is 4. The x's we didn't simplify. And the y's we have now y to the 5th. There's nothing left on the bottom other than the 4. Next, be careful on this one. Anything to the power of 0 is 1, so just this piece is 1. We have 1 times 1 over 4 to the negative 2 power. So anything with a negative exponent, we need to move to the top, move and make positive. So I have 1 times 4 to the power of 2 over 1. Well, if you divide by 1 and multiply by 1, it doesn't really do anything. 4 squared over 1 is still just 4 squared. 4 squared times 1 is still 4 squared. So it's said to leave using exponents, but if you wanted to, 4 times 4 is 16. Next, write a rule for the function. Remember, writing a rule we want in the form a times b to the power of x. A is when you're looking for when x is 0, and b, you're looking for the pattern when you multiply. So first, a here, a is 1/9, and then b, our pattern from 1 over 81 to 1 over 27, 1/9, 1/3, 1, we're going up, we're multiplying by 3. If that's confusing to you, you can see that these are getting bigger or more positive. It's easiest to see between these two right here. 1/3, how many times would give you 1? Well, 1/3, 3 times would give you 1. If you're not sure, plug these ones in your calculator. This is going to be b. So our equation is y equals a, which is 1/9, times b, which is 3 to the power of x. Let's take a look at one more. First, find a when x is 0. Okay, a right here is 4. And then our pattern from 1 to 2, 2 to 4, 4 to 8, 8 to 16. Well, you're multiplying, we're multiplying by 2. 2 times 2 is 4, times 2 is 8. So b is 2. So we have y equals a, which is 4, times b, which is 2, to the power of x. You cannot combine these because our order of operations would tell us to multiply, or not multiply, do our exponent first. So you have to leave it just like this. Alright, we have two more down here. First, let's find a when x is 0, a or y is 2. And then b, our pattern each time. It's harder to tell over here with the fractions, but from 6 to 2, I'm really dividing by 3. However, our pattern is what we're multiplying each time. So instead of dividing by 3, I'm going to say I'm multiplying by 1/3. Because we really do have the division in there. We're multiplying by 1/3, multiplying by 1/3. If you're not sure, plug it in your calculator. See if 6 times 1/3 in your calculator, just like that, equals 2. It should. So our equation will read y equals a. I'm going to write our equation here. A times b to the power of x. A is 2 times b, which is 1/3. To the power of x. Last one here, a is when x is 0, a is 10. B, what we're multiplying each time, this one's also going down. From 50 to 10, I'm dividing by 5, but instead of dividing, we say I'm multiplying by 1/5. 10 times 1/5 would give me 2, so that's going to be b. So we have y equals 10 times 1/5 to the power of x. If you have questions on those, please let me know. And then we had a couple where we have to graph. It says graph the function, identify whether it's exponential growth or exponential decay. So I'm going to make a table so that I can plot my points. So we know we're going to make an xy table. And we can plug in any number we want for x. However, it's easiest to plug in a couple negatives and a couple positives in order to plot my points. And then x, we're really plugging in right here for x. So first we have 4 to the power of 0. Well, anything to the power of 0 is 1. Then I have 4 to the power of 1. Well, 4 one time is just 4. And then 4 to the power of 2 is 4 times 4, which is 16. Then over here, 4 to the power of -1. If you're not sure, let's plug this in our calculator. Here's 4. Remember, this button means to the power of -1. Gives us 0.25. And then again, we have 4 to the power of -2. 4 to the power of -2. 0.0625. I'm just going to write 0.06. And then we simply have to plot the points. These ones go up by 1s, and same this way, 1, 2, 3, 4, -1, -2. So at -2, I'm at up 0.6, so almost on the x-axis. At -1, I'm up 0.25. At 0, I'm up 1. At 1, we're up 4. at 2 up 16, which is going to be way up here somewhere. We can't really plot that one. So draw yourself a nice curve there. It's going to get really close, but we're not going to touch the x-axis. It says identify whether it's growth or decay. Well, this one from left to right, we're going up, so I know this is growth. You can also see our numbers as we go across are getting bigger. They're growing. Let's try another one. I'm going to make a table. X and Y. And then plug in the numbers, same numbers, -2, -1, 0, 1, and 2. So I'm going to plug these ones into my calculator as well. First, I know, well, 1/4 to the power of 0 is still 1/4, or as a decimal that would be 0.25. Oh, no. Made a mistake. Anything to the power of 0 is 1. That's just 1. Here we go. 1/4 one time is 1/4, or 0.25. Then we have 1/4 two times, or 1/4 times 1/4. I'm going to plug this in. 1 divided by 4 to the power of 2 gives me 0.06. And then the other direction as well, 1/4 to the -1 power, 1/4 to the power of -1 gives me 4. You know -1 is really just going to flip this fraction around, so it'll be 4 over 1, or just 4. Same thing here, but with a -2. So 1/4 to the power of -2, 1/4 to the power of -2 should give us 16. If you notice, these two graphs are actually backwards of each other. This one's 4th and this is 1/4. So this is growth. You can assume this one's going to be decay, because as we go across here, our numbers are getting smaller. So 16 we're not going to be able to plot, but at -1 we're up 4, at 0 up 1, at 1 up 0.25, and then almost on that x-axis. Missed that point a little bit. Do your best there. You can maybe move this over. Oops. Draw your line through all of our points. And this one, just like we said, is a decay function because we're going down from left to right. All right, last one. It says graph this function and compare it with this graph. Identify the domain and the range. Well, we just graphed this, so I'm just going to copy the table from back here. Right here we graph that same thing. So xy, I'm going to make my xy table go this way this time so that I can graph both functions. I'm going to put this one 1/4 to the power of x here, and then -3 times 1/4 to the power of x here. And then we're going to plug in the same numbers we've been plugging in. -2, -1, 0, 1, and 2. So like I said, back here we had 16, 4, 1, 16, 4, 1, 0.25, and 0.06, I think. Where are we? 0.06, yep. So now I need to do the same thing. I already have this graph right here, so I just need to multiply all these numbers by -3. So 16 times -3 gives me -48. I know I'm not going to be able to graph that one. 4 times -3, you should know this one, -12. 1 times -3 is -3. 0.25 times -3, a quarter, 3 times would be 0.75. And then 0.06 times -3, I know it's negative. 0.06, or 6 times 3 is 18, so it's going to give you 0.18. So now we just need to plot our points. So I'm going to start with this first two columns here. So at -2 up 16, that's not going to fit, so I'm going to cross the 16 off there. At -1, I'm up 4, 1, 2, 3, 4. At 0, up 1. At 1, I'm up 0.25. And at 2, up 0.16. So draw a line through there. We know it's going to look something like this. Oopsies. Try and draw a nice straight curve. Get rid of this little piece here. There we go, a little bit better. And then we need to compare it to this one. So this one, negative 48 and negative 12 aren't going to fit, but at 0 I'm down 1, 2, 3. At 1 I'm down 0.75, and at 2 I'm down 0.18. So this one is going to be similar, but you notice even from 1 to 3, this is further away from the x-axis. So what do we call that if this number itself is bigger than 1? It's a 3. So we call this a vertical, oops, this is a T, vertical stretch. Because it's bigger than 3. It's moved away from the x-axis here at 0. This one's only at 1, this one's at 3. And it's also flipped over the x-axis, it's on the other side, which we call a reflection. So reminder that if this was a shrink, your graph would be closer or like between 0 and 1. If you have questions about that, please let me know. Otherwise, the last thing that we need to do is identify the domain and range. You can do so for both. On the top graph, our domain, what we plugged in for x was anything. We could have plugged in any number, so all real numbers. And then our range is just all positive real numbers, because we have all in the positive for the green one. But then for the red one, our domain, again, we could have plugged in anything we wanted, all real numbers. But then our range, our y values are only here in the negatives, and they're all down here on the bottom. So all negative real numbers. If you have questions, please let me know. Otherwise, we have a test coming up.